Okay, guys, Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Very good afternoon, all students joining here. So, today we have a different topic, which is about, I think it's chapter 6 here, not chapter 7. It's about association and aggregation composition. You have three different terms, which are very important that you will use in your design. When you design the class diagram, you have to find what kind of relations that will connect these classes or objects. So you have to understand how to differentiate between these three terms. But before I start here, I'd like to see your feedback about the test. How do you see the test? Can you view the marks of the test? Because I already update the settings to make it visible for you. Can you see the marks here? Can you click the links here? You see your mark. Is it clickable or still not clickable? Anyone can
Cannot
say?
open.
Can it be
Can,
like this?
cannot.
Mhm.
Can't open.
All cannot open.
Yeah.
Okay, I try to make some updates here in the settings to see, because here I already make it visible for you. A few options here. After the quiz is closed, you can see the marks here. I'll update the restrictions here. So if I change must not restrict the access. Okay, so I will save now. Must not. Please check. It's visible now. Can you go in?
Yeah, it's working now.
All right, so you can get feedback about your test here. All bars, I think, are visible now for you. All right. This one, I need to change to. All right, so I'll update settings here. Restrictions. Okay, I'll flip the condition. Okay, guys, I hope you do well in the test. Later, maybe we'll check out. Okay, guys. So, any question about the test level? You see, how do you see the level of the test? Is it difficult, medium, or uh, anyone want to say something about the test?
To me, it's medium. Some I can answer, but then some I really couldn't answer. So it's like 50-50.
50, but you cannot answer because of not covered or difficult or time is limited, or if you have more time,
that
can you solve
that
it?
that one I really don't get it. Yeah,
I
it's a matter
you
of
didn't
knowledge lah,
get
not
it.
time. But then
Uh,
for objective, it was quite hard. Not hard lah. I mean, it was quite time consuming. I think, to be honest.
for part one, multiple choice, you mean? Which one is more difficult, the structured one or multiple choice?
The structure.
Structured one. Actually, we are 9 lectures here, so different opinions. You will see maybe everyone have different perspective. My part was in the multiple choice. Even it's very small part because, as you know, we are 9 lecturers there. All must contribute in the test. I hope you will do well in the take-home test or 25. We call it technical skills. Yeah. So I hope that you will get another chance to get better mark. Okay, guys, we will go back for the materials today. So
Doctor,
yes,
is it out of 10% or 15%?
I think 15. 15. We have one is 10, one is 15. If we refer back to to the guidelines here, introduction. So you can see the distribution of the marks here. The last one. So you see here we have this is coming skill-based test is only 10, but this one midterm is 15. Okay, so 15 this one should be.
Okay, thank you.
The coming one is 10. Come. All right, you have another chance in the project, which is 20 here. Assignments also you have 2 assignments, so it's you have more chances coming. All right. So for the labs we have only 1 because accidentally we lost all the content when we recover the test. So previously I told you you have bonus tutorials and assignment, but we cannot redistribute again. So we will focus only on the labs here. So we already covered lab 1. I give you 1 week to submit. Then we have lab 2. We will make it in the second half. Lab 2, lab 3, lab 5, all will be in the second half. We have 4 labs here. Okay, guys? All right. So today topic, which is about association, aggregation, and composition. So basically, when we mean by association, it is a relationship between 2 classes. If you have a class A, so we have 2 classes. This is class A, and this is class B. So we have some kind of relation from A from B to A, or the opposite maybe. A has a relation with B. So we can call this association relation is has. So maybe a student has, so it's coming from here to here, has a teacher, or teacher has a student. So both. There is no parent in this relationship. All equal. You can say from A to B or from B to A. So this is the association. It could be one. So we have one teacher here has or supervise one student. So it's 1 to 1. We have one supervisor for one student only. Maybe 1 to n, one teacher teach n students. Not supervise, here supervise only 1, but teach many, it's n. Also maybe at the same time, maybe the student, one student, has many teachers. You have many subjects here. Or the fourth one, we have n to n. We have many students here linked to, so it should be like this. We have 1 to 1, 1 to 1 here, many, so it will be n to n. All right, so now association indicates a relationship between classes through their objects. So how you create this link between A and B, assuming that we have 1-to-1. We have one student and one supervisor. So now different classes. This is class, let me make it here. This is the class student is here and the teacher is here, or supervisor, teacher. All right, so now I have this kind of relation. So the student has a teacher. Sorry, so it's 1-to-1. How to create in the programming? So first, you have to create this class. This is class S. Then you open, close. You have the private section. You have the name here, which is string. Then you have the ID, blah, blah, blah. All the attributes and functions. Then you have another class here, which is the teacher. It's the same. We have attributes. You have the name of the lecturer here, the ID, and so on. All right. So there is currently how to implement this link. How I can create a link between these two independent classes. This is class T, teacher or lecturer. If I change this one to L, he will be the lecturer. So how to create the link between these two classes? Using what? Using object. So I want to create a link from S to L. The student has a lecturer. So where I have to put the instance, the student has a lecturer or teacher. So I have to put it here inside this one. So inside this one, in the private section, I have to make a class of type L. This is my lecturer or my supervisor and so on. So I have an object here from this one. All right. So if you have 1 to n, you have many teachers. Teacher 1, teacher 2, teacher 3. So what you have to do, but different names. They have the same attributes, but different names. So what you have to do, you have to identify an array here. All right. So array will give you the ability to link to many. Okay, guys. So now association indicate relation between through, this is the most important thing here, through what? Through their objects. You have to create an object from another class, so you have association relationship. So association can be 1-to-1, 1-to-many, many-to-one, or many-to-many relation, as I have explained. All right. Okay, so we have examples here. We have a lecturer teaches a student, or this is 1, or maybe 0. There is no students with this lecturer. It's still new, 0 relation. And this is stands for n. Maybe you have 1 student, 2, 3, up to n. So we have another example here. A lecturer advises student. So different roles, you can see different roles of the relationship. Now teaching role, but now we have advising tool. So he is the course advisor for you. Then we have another examples of this kind of association. A lecturer may be the supervisor of postgraduate students. So it's still 1 to star. This star may be 0 up to n. 1 to n, maybe 0 or n. All right. So you can see now there is no parent in this relationship. You can make the opposite. The student has a lecturer. The student has advisor. The student has supervisor. So there is no parent in this relationship. All right. So now the second one, which is a special version of the association, we call it the aggregation. So what's the difference between the first one? The aggregation is a special type of association. So what's different here? Which is one way. So it's one way. You cannot make the opposite in the relationship. So direction is only one way. So this is the first characteristics. The second one, it models has a relationship. You can see a teacher has students. So you can explicitly mention like this. You have some kind of including and enclosed. Enclosed is the other part. So this is second characteristic. The existence of this third characteristic, the existence of an object enclosing are independent. Meaning that if this in the previous one, if you delete this class will not be deleted from the system. You just delete the relationship, so it's still there, this class. Okay, so it is what we call it, they are independent. In that case, if you destroy one class, it will still exist. All right, so we have here an example of the aggregation. So we have a relationship between the money. The money has a relationship with the wallet. So meaning that who is the owner in that case? The owner is which one contains the other? Is it the money contains the wallet or the opposite? So the wallet is the parent. You can call it, this is the parent here. So this is the parent. So it has a relationship. So you can see our wallet has the money. So this is the parent and this is the child. Okay. But this relationship is independence, meaning that if there is no money, destroy this object, you can have this class. You can create this class, but it's empty. Okay. However, money does not necessarily need to have a wallet. Also, the opposite. You can have a money without a wallet. It's still true, this aggregation. So the dependency is a little bit weak as compared with the third type that I will explain later. So money contains, you see, this is the most important. So many objects can be created though even though there is no wallet object. All right, so the child can exist without the parent. It's not necessary to have the parent. This is the key point. But in the previous one, you cannot say parent child. They are equal, same. A student has a lecturer. A lecturer has a student. There is no parent in this relation. So it's more general. So if we make it like this, so association is at the top. So any relation you can call it association. But inside, we have a special one, which is the aggregation. So the aggregation is subset of the association. We have a relation, but this is special relation. You have to put the diamond here, sorry, at the parent. So you have to be careful about the symbols. So it is a special type of association, the aggregation. We have one way. You cannot make the opposite like this. You cannot say money has a wallet. This is wrong. So it's one direction. So the parent comes with this symbol. You have to be careful about the symbols here. All right. Clear this point. You can differentiate between aggregation. Association is any relation, but aggregation is a special one. We can create parent and child, but still this relationship is independence, meaning that you can have the child without the parent. So aggregation is implemented. How you can implement this? By a pointers. You create a pointer that will be pointed to the address of the object. So we have to use the pointers. Sorry. It's because the existence of the including and includes object are independent. So that's why we are using pointers. Because what's the benefit of pointers? You just give me the address. The object is already in the heap. So this is the heap memory is here. So the dynamic memory, your object will be here. Then you just take the address here. So what you need here, you just make this address pointed to null. So meaning that there is no relation. Okay. It's because the existence of including and includes object are independent. So if one party is destroyed, the other one still exists. So this is one important features of aggregation relationship. So the relationship between object can be broken by only disconnecting what? The pointer. So example here, consider a course registration system. So we have a student class. We have two classes now. We have student and the course. So can we see a course has a student or a student has a course? Which one is the parent in that case? Any idea? So
The student.
the student, yeah, student has courses, of course. Assuming that the student quit, you drop this course, but this course still exists. You cannot destroy the course. In that case, his or her record will be removed from the system. However, the course needs to remain as other students are still enrolled in that course. So the relationship between the students and courses should be done via aggregation. All right, so we have here the coding part, the implementation. So aggregation declared attributes as object pointers. The pointer can be set to null to represent there is no relation or no object. So you see here, this is our class student. Then we have another class here. We have another class, which is the course. Okay, so this is the second class here. So to create the link, the student has, so this is the direction of the relationship. The student has registered on this course. So the diamond should be here. Okay. And you have to use pointers in order to just delete. When you create the link, you have to call this function enroll the course. So you have to pass a pointer only. You have to get the address of this course from here. So initially, the constructor will make this pointer point to null. But when you set, this is setter. Enroll, it's equivalent to set a course. You will pass the pointer, then you will set this course equal the pass value here. Withdraw, you just delete the pointer. No need to destroy this object. The object will be there. Okay, so now you will see you just assign the pointer here. So the relation is done. So the course should be passed rather than object, it should be passed by a pointer. Okay, because this course is already shared with other students, so you cannot destroy this course. So in case of withdraw, you just set to null. Of course, you cannot say delete this course, you just set this pointer to null because the pointer in the student class. And when a student withdraw the course, we just need to break the link pointing, not deleting. The course, other student might still be using the course. Okay, so this is the main here. We have a class course. So first you have to create the course in the database. You have to give ID for this course, abbreviation, and so on. So this is the course, which is shared. Then I need to pass what? Pass a pointer to create the relationship. I have student 1, student 2, student 3. So these students will point to this course. So I just passing by pointer. So passing as a pointer. So the student is deleted from the system. When you delete the object of the student, after you set to null, you can set to null the pointer. Then you can delete the student object, not the course object. We are deleting the student here. So the student is no longer exist in the system. So the student is deleted from the system as he or she has dropped out from the study. However, the course still exists. Okay, so I'll show you the coding before we move to the last relationship, which is the composition. To show you the coding part here, you have to discard. Okay, then we have a class of student. So student class here. You have the private section here. So the private section, we have a course class. So we have 3 functions here. The constructor, this is a constructor here, function for enrollment, and no need for the dot here. Okay, we have another class. We have the implementation of these functions. So we are implementing these functions here. Withdraw, enroll. Okay. Then we have the main here. So this is the main program here. I'll change this one. Okay, so the first step here, what you have to do is to create the course. Okay, so we are creating a course here, then we need to pass by pointers. So we don't have the course class right now. We will try to build one. Sorry, this is double quotation here. Double quotation here. So it's programming technique here. Programming technique 2. This is the name of the course and this is the ID. So we have to create another class which is the course. So we have two attributes here. You have two strings. We have string here, the ID and the name. So this is the code and the name of the course. All right, so we will use the default constructor. The default constructor will be generated by the compiler. So now what we have also, we have this instance, then we have the student here. We are calling because we have a pointer here. This is new student here. Okay, so this one. Okay, because we are using new, so you will receive address for this object. Sorry, this one S3 here. This one no need. All right, I think all are okay. We will execute here. Let me see the logger here. Okay, so the students withdraw. Let's run here.
The name of the function, withdraw subject and withdraw course.
Yes, right. Withdraw subject, withdraw course. Yeah, it should be withdraw course. Thank you. Withdraw course, enroll course. It's enroll course, right? Okay, so now the constructor here, and to view the error. So done parsing a second. We have not the default one because we are passing parameters, so I have to implement the constructor here. So the constructor must be implemented here. So this is the course. So we are receiving two strings, C and N. Okay. So we will see what we have to make string copy. Okay, we'll use one character just for illustration here, char. So you see, so the code here equals C and the N equal the name. So one character, we will pass only S and 2. Okay, so code equals C, it's char. We pass as a char. Code equals C. Oh, sorry, this is char. A new student here. New student. Okay, where is the constructor without parameters?
I don't think we declared S1 as a pointer.
Sorry.
S1 is not declared as a pointer.
Yeah. First, you need to declare as a pointer, then we have to assign. So S1 as a pointer. Then we can create an object. Okay, thank you. So what's going on here? We don't have any output. We just create a relationship between the course and the student. Okay, guys, clear the relationship using a pointer. You have to use a pointer as the link between the student and the course here. Okay, this is the key point, how to link two classes using a pointer. Okay, you just pass by address here. So you'll set the relation from this function. Okay, guys, any question before I move to the last part, which is composition? Is it clear how to create this relation between two classes using the aggregation concept? All right, we have the last kind of relationship between classes, which is the composition. Now, in the case of the composition, it is more specific. We have more restrictions of this relationship. So what's the difference now? So we have a restriction. It's a restricted version of aggregation. So if you look back, the parent here is the association. Any relation you can call it association. Inside, we have the aggregation. So aggregation comes inside the association. Inside this one, we have the composition. You must understand this kind of enclosing. So composition is a restricted version of aggregation. Aggregation is a special version of association. Association is any relation you can apply. So at the beginning, you make it, you try from here. When you check what kind of relation, you start checking here. Is it composition? You have to ask yourself. If this relationship is composition, if not, you have to ask here. Is it aggregation? If not, it should be association. All right? This is very important to distinguish in the design. Your design, you have to specify which kind of relationship. So it is a restricted version of aggregation in which the enclosing and enclosed objects are highly dependent. In the previous one, there is no dependency, meaning that if one is destroyed, still the other exists. But now we have a highly dependent relationship between them. So the existence of the enclosed is the parent. It's the child, sorry. The enclosed is the child. And the enclosing is the parent. So here, the existence of the child object are determined by the parent object. If the parent is not exist, if the wallet is not exist, meaning that there is no money, but you cannot say like this. We have different examples for this relationship. But you have to be careful about these characteristics. If the parent is destroyed, so automatically the child must be destroyed. So it models the whole part relationship with a strong ownership. When the whole die, the part does so. When the parent die, the child must be die too. So enclosing object has, you can say, the relationship object A has object B, contains object B, contains of enclosed part. Alternatively, the enclosed object part of the enclosing. You can opposite the direction. You say the child is part of the parent. So an object can be only part of one whole object. So you can see we have some kind of component. We have the parent has some components inside. If the parent destroyed, automatically the components will be destroyed. We have an example here, like the house. The house, this is the house object. The house has what? Has the rooms. So room 1, room 2, room 3. If the house is destroyed, so automatically the rooms should be destroyed. Okay, you can see this room is part of, so you see when you opposite the relationship. A room is a part of the house, and the house contains rooms. All right, so you have to try like this to distinguish what kind of relationship you have in your design. Okay, we have another example here is the body. So the heart is part of the body, and the body has a heart. So A is a whole part, so this is the parent. You can call it the whole part. Relationship, a human body consists of, has, heart, or the opposite here. The heart is part of the body. So the dependency here, a human body needs a heart to live, and the heart needs a human body to survive. You cannot have a body without heart. You cannot have heart without body. So body object is destroyed, then the heart object is also will be gone. When a body object is created, the heart object also, you cannot have a body without heart. You must create the component inside. All right, clear this point. So it's very restricted relation. You have to try first to check if this kind of relationship is a composition. So you have to use the diamond here, but it is filled now. You see the symbol here? We are using the diamond here, but it is filled here. In the previous one, it's empty. And in the association one, you have only link. Okay, clear this point, the symbols, UML symbols that you have to use in your design. So now we have the examples here. We have a book with chapter. So now the relationship between the book and chapter, you can see a book has a chapters. So in case you destroy the chapters, can you have the book without chapters? Of course, no. So this kind of relationship must be composition. Clear how to check if this kind of relationship of composition. You try to destroy one object and see if this class can be without the other parts. So composition is implemented by nested object. The whole object contains a part object. It is because the existence of the whole enclosing and part enclosed object are dependent. Okay, clear this relation, how to distinguish. So we have the example now, how to create the link now. Now, okay, we know this is composition, not aggregation. In the case of aggregation and association, you have to use pointers, because if one is destroyed, the other one must be exist. But now, how I can implement this one, and I make sure that if I delete this object will be automatically deleted. How can I do it and implement it in the code? So you see here, we have the chapter now. So this is the chapter, the parent class, and where is the child? This is the child. We have the chapter, we have the book, which is the parent. Now we have the number of pages of this chapter. This is the constructor here. We have the getter. Then we have the implementation. It's just implementation of the constructor. Then we have the getter here. So it's nothing new. I have a simple class here. Takes an integer. So the constructor for the chapter class takes an integer argument to define its pages. So now I have the book, which is the enclosure or the parent. Now the book usually comes with many chapters, but now these chapters, you cannot define them as a pointer. You cannot say it's pointer that will be pointed to the chapter object or class. So you have to define them as instance here. You will make a copy. You have to create inside this one. This is the template here. You have to create objects. So this is the first object, chapter 1. We have another object in the memory, chapter 2. So it's independent from other books. So each book must have its own chapters. Okay, so the main difference here, you have to create by instance, not as a pointer. So as objects here. So include objects here, you see, of class chapters. Then how to initialize these objects now? You have to be careful about this. To initialize this private, it's public here. To initialize using the constructor, this is the constructor of this class. So I have the parameters. I need to initialize the number of pages for chapter 1, the number of pages for chapter 2, the number of pages for chapter 3, and so on. We have chapter 4 here. It will be linked to this one. So now you can see we are using the colon operator. The colon, then I will call what? I'll call the constructor of the chapter object, and I will pass the parameters here. I'm receiving parameter here, and I'm passing at the same time. You see the kind of coding here. So I'm receiving in the constructor, and immediately here I'm passing after the colon. I'm passing this parameter to the first object. I'm passing to this parameter where the second object, and so on. So we are using a colon in the constructor. So you see here, this is empty. In the prototype itself, you have to add the colon operator here to initialize the enclosed. The enclosed, it is the child, the enclosed object. All right, after initialization, you need to show the number of pages. So what you have to do here to access the page numbers, how to access, you need to access through these objects. So now you see here, object one, you will call the method inside the object one to calculate the number of pages. So you have to call the getter. You will call the getter here. This is the getter. You will call it through the object. That's why we are making this part in the public, sorry, in the public section shown here. If you move it here to the private section, you cannot use it like this. So that's why it should be public here. All right, we will try to code this example. I think this is the last one. I'll just show you the coding part. Okay, so we have the first class, which is the chapter. This is our first class here. Then we have the second class plus the main. So the second class and the main program is here. All right, so this is the main here. We'll check if there's errors, obvious errors. So this is a constructor here. This is second class here. We have the colon here. Okay. So in the constructor, we need to use the so we are doing the calculation here, just calculation plus see out here. Okay. We'll try to execute. All right, so no errors here. So what you'll see, the number of pages, because here I'm initializing what I'm doing here. I'm calling the book. I'm creating a book first. So you see, it's just one statement. No need to create what? To create chapters. I'm not creating any chapters. I'm directly here creating the book. I'm creating the book directly. So assuming that each chapter with 100 pages. So assume that you will see here the number of pages will be 400. Okay, 400 here. We will execute. Okay, clear this point, how to differentiate between the composition and aggregation, and how to implement the composition. This is very important to be used in your design. If you use the pointers, we will be wrong. Okay, clear this point. Any question? You can differentiate. You can check if this kind of relation is composition or not. You will start with the smallest one. If not composition, you will check if it's aggregation. If you can create a link between someone has someone, it's one way direction, but you can say has. You cannot make the opposite. To check for aggregation here, you will check from this side. Can you say Amani has a wallet? This is cannot be done. So meaning that you have to use the aggregation. But if you can say money has a wallet, it will be the standard one, which is the association. Okay, clear this point, how to use the appropriate UML diagram.
Can you open the book class?
Sorry,
Book class,
the book, this one, yeah,
the coding part.
the coding part, okay, in the coding,
Yes, better to show it in code blocks.
okay.
Okay, the constructor of book after the parameter list, the C1, we initialize C1, C2, and C3, and C4, right?
Right.
Can we initialize the same like C1, C2, C3, C4 instead of initializing it with the parameter list, initializing it inside the function?
Inside the function,
Yes.
but this is direct here. You cannot, if you don't use the direct initialization, this is direct initialization. You can initialize in a function, but in that case, you have to use the setter after, right? This is what you call it, this is short coding. Directly you create and initialize
Okay.
to save the coding, because if there is no initialization here, if you take out this one, we don't prefer to you mean inside the
Yes,
constructor here?
inside the constructor in
Sorry,
line
sorry,
52.
sorry. Now we are calling this class. So what you have to use here, you are calling from the constructor, you are calling another constructor. So what you have to do here, okay, one by one. We'll try and see what's going on here. Is it allowed or not? Okay, so this is second one here. Sorry, this is second one here. Then we have another one here. All right, so no need for this semicolon. We will try. Oh, sorry, we just passing. Okay, we are calling. All right, so I don't know what's wrong here. I cannot see the error. Okay, I'll try to close and open again here. This is new. Okay. Okay, untitled is okay. So I'll execute here. View. Okay. Okay. It's floating. So to do personal.
Can you make the line 27 with 26? Put the parameter list all in one line.
20, 27. In one line. Okay. 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 Now what's the error? Error is here. So without initialization first. Okay. We must use the. So we will return back to the original one. Oh, sorry, we don't have the copy. I think we have to use the. It's compulsory. You can refer back to the book if this operator must be exist. Okay.
Okay.
You can return back to the book to check if this is compulsory. Must be like this. So note use colon operator to initialize the enclosed object using their constructor. This is the right way to call the constructor. Maybe you cannot call from inside. All right. Any question about the relationship? How to differentiate between these relationships? Because it's very important that you will build your class diagram based on this kind of relation. So you have to distinguish from the beginning which kind of relation that you are going to use. Okay, guys, if no question, this is the end for today class. I have to stop my sharing here. Then I have to stop the recording here.